Then the next topic is to discuss about the special addresses. We have some blocks of addresses which are assumed to be special address, and these addresses are not assigned to any host machine, but they have this specific meaning. They have the special meaning. The first address is all zero address, where we write all the 32 bits equal to 0. Means 0.0.0.0. So this is block is said to be a special block, and this address is special. Now we are using this address for two purposes. The first purpose is we are using it to find its own IP address. So whenever the machine wants to communicate, it needs to know its own IP, because this has to be right in the packet. When the packet is delivered, inside the packet there is the information of the source IP address. So this IP is required. So what the machine is doing, whenever it wants to deliver a packet, it will create one packet with the source address 0.0.0.0 and the destination address 255.255.255.255. This is a broadcast, and this is delivered in the network. So this packet goes to the DHCP server. Normally this is a software which is running at the router machine, which provides the IP. So this packet is delivered, goes to the router. Router will take this packet and read that 0.0.0. That means this machine wants to communicate in the internet. It will assign one IP, and then this IP is delivered to the sender. Okay, so the first purpose means one of purpose to write 0.0.0.0 is to get its own IP. IP addresses are not fixed; they keep on changing. Whatever the IP you are having at this time, it will be means when you start your computer, it may be changing it. Okay, so every time we are getting a new IP, and this is provided by the DHCP server. The second usage of this 0.0.0.0 is for a default route. Now this entry is also used in the routing table. As we discussed, the routing table is maintained at the router. Router maintains some information which helps the router to forward the packet. Whenever the packet goes to router, will check the destination address and then decide where to forward this packet. So there is a possibility the destination address which is in the packet is not matching with the entries which is in the routing table. So in that case, it will send to the default route. So actually in the routing table we have some entries, and then also we have a default entry. It is the same thing like we have switch case, right? Case 1, case 2, case 3, and then the default case. So whenever any packet goes to router will search in its table, and if the address is not found in the table, it will send to the default interface. So there is one entry that is for the default. If nothing is found, then forward it to this particular default interface. So these are the two uses of this 0.0.0.0. So this is how it is used. This is used by the sender machine to know its own IP. Then other special addresses, all bits are set to 1. When you set all bits equals to 1, it becomes 255.255. So this block is also a special, and this is for a broadcasting, and this broadcasting is set to be limited broadcasting. Limited broadcasting means we want to deliver a packet to all the host machines which is a part of the same network. So limited broadcasting means broadcasting in the same network. So whenever any packet goes to the router with this destination address 255.255.255.255, the router will block this packet. This packet will never be allowed to leave the gateway of that network, because this packet is actually to be delivered to all the machines which is a part of the same network. So this is how the things are working. If this packet wants to send to all the machines, it will write the destination address as 255.255 means all bits are set to 1, and this is delivered to all the machines. When it goes to the router will block it and not allow to leave this network. Then the next is called loopback address. So this block is for the loopback block. So 127.x.y.z. So it means if you write 127.0.0.123. So this is again used for two reasons. One is to check the network layers. Means you need to check that the layers on your machine is properly configured or not, they are working properly or not. The sender side we are having a layers, and the receiver side is also having a layers. So the sender who want to deliver the packet, we have the software is having the layers. So we have application layer, we have a transport layer, we have a network layer. So when you send any packet, so how do you check? You will use the ping command. You will write ping 127.0.1.2 whatever you write, and if you get the proper messages, that means the software is properly configured, and you can use the ping command and you can send the message in the internet. Means you are connected with the internet and your software is working properly. If you are not getting the proper ping response, that means something is wrong with the software working at your machine. So this is used for self checkup of all the layers which is at the source machine. The other use is if the machine is using as a client and server, then also you will be sending this 127 dot some number dot some number dot some number. This is how you can check by using this block 127.0.0.0. So it goes from the same machine, it is sent and then delivered to the same machine. So if you are getting the proper response, means your machine is correct and you can easily test it. Then we have some blocks of addresses which are said to be private addresses. So we have two kind of addresses. One is called public addresses and one is called private addresses. Now these private addresses are the blocks which are assigned for a private network, and these are the addresses which are not used globally. This is only for the local identity. Every machine which is a part of internet must have an IP address. Okay, so let's say as an organization I have a network which have 100 machines. So what I will do, I need to assign an IP address. So these IP address I can provide to my machines, but these identity as an IP will be local in the network. It is not visible to the outside. Means if I am sending any packet to the outside world, if I am sending some message through a Rediff mail, and my IP is something 10.0.9.6. This is my IP of my source machine. If I am sending a packet, then when the packet leaves the network for which I am a part, the source address will be changed. So global IP is different, means every network is having a global IP. That is the identity to the external world. Means we are working on our machines. All machines are having IP, but when you deliver some packet, your source address will be converted using the global IP. Is that okay? So private IP is for the local identity within the network, and this is the external identity. global communication. Now why this is required, why actually we are doing like this? If we go in this fashion, then we can save lot of IPs, because it is realized that all the time we are not connecting or using the internet. There is no need to assign the global IP to everyone. We have a limited IPs, right? Limited means we have only 2 power 32 IPs are possible, and this is actually very less. If you look at the number of users and if you look at the number of IPs available, these are very less. So we have realized that at one time not all users are connected to the internet, so we are not assigning these IP to everyone. So what we did is, we have a concept of private and public. With the private IP, now again, when I say private IP, one IP within the network can be used again with the another network. So if there is an IP called 10.7.1.2, this is one IP of any machine in the one network. In other network again we have the same IP, this is possible. So if we have two networks, and here one IP is assigned 192.168.1.2, then within this network you don't have this IP, but the same IP can be used here. Why this is used here? Because these IPs are having a local identity. When they go outside, means when this host machine which is having this IP, when it goes outside, this IP is not reflected. It is having a different identity. What identity? Actually for this global, for this entire network we are using one IP, let's say 220.6.1.2. Now this is the global IP. So all the machines which are a part of network will use this IP when they go outside. So actually what we have achieved that we are, by using only one IP, we are able to communicate 100 or 2000, 200 or 1000 machines. If this network is having, let's say, 500 machines, then these 500 machines can be able to connect with the internet using only one IP address. Yes, now your question is how we can transfer data from here, this machine to this machine, right? So again, this machine is only for the local network. Actually this identity is different. Maybe we have one global IP. Now for this network we have this global IP. Similarly for this network we have 230.1.2.3. So the identity of this particular machine is this as a global, and the identity for this machine is this as a global. So whenever the packet is delivered from this network outside this network, it will carry this IP, and whenever any of the machines from this network will go outside, will carry this IP. So it seems like very simple, but we will realize that there is so much complexity is there. So how it is identified that this global IP is given to this machine? Because there are 100 machines are there. So that means there we need to maintain some table which will maintain the entry that this packet is delivered, and for this packet I am using this particular IP. So whenever any packet comes with this IP, I need to send it here. This can be managed. If we have only one machine existing here, it seems very simple, right? But if we have many machines, then how to handle this? We will see this. There is a concept called NAT, network address translation. We have a table that maintains everything. So initially this is the idea, but when we go deep into it, we will find that there are so many complexity. It is not straightforward. And then again we have a problem, we have a solution. With new solution we have a new problem. Now we have two solutions for this. We may increase number of global addresses, that will resolve it. But again the question will come, how many global addresses we will increase? So we will come up with new solution. That I will show you here. So this is the block of private addresses, and this is used for private identity within the network. Then we have something called network address. So network address is the first address of the network. This is the identity of network. First address is also the identity of the subnetwork, and this is special. In the block, the first address and the last address is always special. So first is network address, And the last is actually used for the broadcasting, and this is called directed broadcasting. So what does it mean? So we have two broadcasting. One is called limited broadcasting, and the one is called directed broadcasting. We have two forms. So limited is for the local network, and directed is for the outer network, or you can say external network. What does it mean? It means if you have a network, and if these are the hosts in this network, if one machine want to send a packet to all the other host, then we are doing limited broadcasting. And in this limited broadcasting, how we can achieve this? We have to write the destination address as 255.255.255.255. So whenever any machine, any host will write this as a destination address, that means you are doing a limited broadcasting. You want to send this packet to all the hosts in the same network. But let's say there is another network, and the network ID is, let's say, 220.10.0.0, and we have many hosts are here. If this machine want to deliver a packet to all other machines, then this is called directed broadcast. Means you are doing a broadcast but in a different network. So in this case, what you will write? You will write destination address as 220.10.255.255. This is called directed broadcast. So directed broadcast means you are sending to other network. Limited broadcast means you are sending to the own network. So limited broadcast, you will keep all the bits equals to 1. Directed broadcast, you keep host bit equals to 1.